In this module, we're going to talk about AWS foundational services. Foundational services such as the Elastic Compute Cloud, or EC2, Amazon Virtual Private Cloud, VPC, and Amazon Storage Services, including Simple Storage Services, S3, and Amazon Elastic Block Store, EBS. To understand Amazon Compute Cloud, EC2, concepts, we have to talk about instances versus servers, types of instances and their families, ephemeral versus persistent storage, Amazon machine images, and bootstrapping using user data. Amazon EC2 instances are virtualized servers in Amazon's data centers. Amazon EC2 is designed to make web-scale computing easier for developers. With Amazon EC2's simple web interface, you can obtain and configure capacity with minimal friction. It provides you with complete control of your computing resources and allows you to run on Amazon's proven computing environment. Amazon EC2 reduces the time required to obtain and boot new server instances, which helps you quickly scale capacity as your computing requirements change. Amazon EC2 changes the economics of computing by allowing you to pay only for the capacity you actually use. Amazon EC2 provides the tools for you to build failure-resistant and failure-resilient applications and isolate the applications from common failure scenarios. Amazon EC2 presents a true virtual computing environment, allowing you to use web service interfaces to launch instances with a variety of operating systems, load them with your custom application environment, manage your network access permissions, and run your image using as many systems as you need. You can programmatically scale your computing capacity as your requirements change. You pay only for capacity that you actually use, and you can choose Linux or Windows. You can leverage the AWS global infrastructure to deploy across regions and availability zones for reliability. Before you create your first Amazon EC2 instance, decide in which region you want to have that instance. The AMI comes pre-installed with many AWS API tools and with Cloud Init. AWS API tools enable scripting of important provisioning tasks from within the Amazon EC2 instance. AMIs are like building blocks of EC2 instances. They are templates of a computer's volumes. AMIs can have public or private access. You can also create gold master images of your Amazon EC2 infrastructure, which allows you to decrease your boot times. An AMI is a template that contains a software configuration such as an operating system, application server, and applications. You use an AMI to launch an instance, which is the copy of the AMI running as a virtual server on a host computer in Amazon's data center. You can launch as many instances as you want from an AMI. You can also launch instances from as many AMIs as you need. You can create your own AMI by customizing the instance that you launch from a public AMI, and then save that configuration as a custom AMI for your own use. You can also buy, share, and sell AMIs. You select an AMI based on region, operating system, architecture, launch permissions, and storage for the root device. Launch permissions determine the availability of an AMI and are either public, where the owner grants launch permissions to all AWS accounts, explicit, where the owner grants launch permissions specific AWS accounts, or implicit, where the owner has implicit launch permissions for an AMI. You can launch multiple instances of different types from a single AMI when launching an EC2 instance. An instance type essentially determines the hardware of the host computer used for your instance. Each instance type offers different compute and memory capabilities. Select an instance type based on the amount of memory and computing power that you need for the application or software that you plan to run on the instance. Your instance keeps running until you stop or terminate it, or until it fails. Instances are deployed in the Amazon EC2 public cloud or the Amazon Virtual Private Cloud in an availability zone within a region. You can configure security and network access on your Amazon EC2 instance. Customers can deploy to multiple availability zones within a region. You choose which instance types you want and then start, terminate, and monitor as many instances of your AMI as needed using the web service APIs or a variety of management tools provided. Amazon EC2 instances can leverage Amazon Elastic Block Store volumes in each availability zone. Determine whether you want to run in multiple locations, use static IP endpoints, or attach persistent block storage to your instances. Amazon EBS volumes can be saved using snapshots. Additionally, Amazon S3 buckets can be used to store data objects needed by Amazon EC2 instances. You pay only for the resources that you actually consume, such as instance hours or data transfer. Every instance has a life cycle. An EC2 instance can be in one of the following states. It starts with a pending state. When you launch an instance, it enters the pending state and the instance moves to a new host computer. The instance type specified at launch determines the hardware of the host computer for your instance. Running. The running state, where AWS uses the AMI specified at launch to boot the instance. When the instance is ready, it enters the running state. You can connect to your running instance and use it as you would a computer sitting in front of you. When your instance is in the running state, you're billed for each hour or partial hour that you keep the instance running. You are billed for all running instances, even if they are idle and not being connected to. You can reboot your instance through the Amazon EC2 console, Amazon EC2 CLI, and the Amazon EC2 API. It is recommended that you reboot your instance, your EC2 instance, instead of running the operating system reboot from the instance. When an instance is rebooted, it remains on the same host computer and maintains its public DNS name, private IP address, and any data on its instance store volumes. Rebooting an instance doesn't start a new billing instance hour. Shutting down. When you've decided that you no longer need an instance, you can terminate it. The instance will enter the shutting down state. You will stop incurring charges as soon as the instance enters the shutting down or terminated status. Terminated. A terminated instance remains visible in the console for a while before it is deleted. You cannot connect to or recover a terminated instance. When you stop an instance, Amazon EBS-backed instances can be stopped. When you stop an instance, it enters the stopped state. Amazon EBS-backed instances in the stop state are no longer eligible for hourly usage or data transfer fees. AWS does charge for the storage of EBS volumes on stopped instances. You can modify certain attributes of stopped instances, including the instance type. Starting a stopped instance puts it back into the pending state, which moves the instance to a new host machine. When you stop and start an instance, you lose any data on the instance store volume on the instance. AWS and Oracle have worked together to offer customers convenient options for deploying enterprise applications in the cloud. Customers can build enterprise-grade solutions hosted by Amazon Web Services using database and middleware software by Oracle, and can also launch entire software stacks from Oracle on Amazon EC2. New and existing SAP customers can confidently deploy their SAP solutions on SAP-certified Amazon EC2 instances in production environments because SAP and AWS have tested the performance of the underlying AWS resources, verified their performance, and certified them against the same standards that apply to servers and virtual platforms. AWS also provides infrastructure services that allow customers to easily run Microsoft Windows server applications in the cloud without the cost and the complexity of having to purchase or manage servers or data centers. Available AMIs allow customers to start running fully managed Windows Server virtual machine instances in minutes. Customers may also rely on the global infrastructure of AWS to power everything from custom .NET applications to enterprise deployments of Microsoft Exchange Server, SQL Server, or SharePoint Server. AWS and Oracle have worked together to offer customers convenient options for deploying enterprise applications in the cloud. Customers can build enterprise-grade solutions hosted by Amazon Web Services using database and middleware software by Oracle, and can also launch entire enterprise software stacks from Oracle on Amazon EC2. New and existing SAP customers can confidently deploy their SAP solutions on SAP-certified EC2 instances in production environments, because SAP and AWS have tested the performance of the underlying AWS resources, verified their performance, and certified them against the same standards that apply to servers and virtual platforms. AWS also provides infrastructure services that allow customers to easily run Microsoft Windows Server applications in the cloud without the cost and complexity of having to purchase or manage servers or data centers. Available AMIs allow customers to start running fully supported Windows Server virtual machine instances in minutes. Customers may also rely on the global infrastructure of AWS to power everything from custom .NET applications to enterprise deployments of Microsoft Exchange Server, SQL Server, or SharePoint Server. Software launched from AWS customers automatically deploys onto Amazon Elastic Compute Cloud, EC2, which is the AWS compute service. AWS customers use 143 million hours a month of Amazon EC2 for AWS Marketplace software products. The benefits of AWS Marketplace include easy product discovery, streamlined buying experiences, simplified billing, expedited deployment cycles, optimized software capacity, matching spend to actual usage, trusted, vetted, and scanned products. AWS Test Drive provides a private IT sandbox environment that contains pre-configured server-based solutions. In under an hour and using step-by-step lab manuals and videos, you can launch, sign in, and learn about these popular third-party IT solutions powered by AWS and AWS CloudFormation. Choosing the right EC2 instance type matters. AWS has a wide variety of EC2 compute instances. Most are based on Intel Xeon processors. Intel Xeon processors are compatible with the broadest range of ecosystem software, which helps developers develop their application rapidly. IT also values Xeon processors for higher performance and reliability. Each instance type or family is optimized for different workloads or use cases. Within each type or family, we have multiple sizes: large, extra large, 2 extra large, etc. When you choose your instance type, you should consider the several different attributes of each family, such as number of cores, amount of memory, amount of type of storage, network performance, and the Intel processor technologies. Larger instances are better for workloads that scale. In 2016, AWS launched C4, D2, and M4 instances based on Intel's latest 22-nanometer Haswell microarchitecture. They all use custom Intel Xeon V3 processors designed and built especially for AWS. X1 is based on the Intel E7 enterprise-class CPU. Haswell can boost application performance, which helps workloads perform better or deliver faster response times. Haswell instances can also include newer hardware-assisted technologies for workload acceleration, such as AVX 2.0, which doubles the floating point performance for high-performance compute and financial modeling types of workloads. X1 features up to 2 terabytes of memory and 100 vCPUs, uses the Intel E7 V3 Haswell processor, and is designed for demanding enterprise workloads. In addition to the new X1, C4, D2, and M4 instance families based on Haswell with its new host of microarchitecture features, our other EC2 instances are based on Intel Xeon processors. These Xeon processors have important technology features that you should be aware of. Intel AVX is perfect for highly parallel HPC workloads such as life sciences or financial analysis. Intel AES-NI accelerates encryption and decryption of data and therefore reduces the penalty you would pay by using encryption. Intel Turbo Boost technology automatically gives you more computing power when your workloads are not fully using all CPU cores. Think of it as automatic overclocking when you have the thermal headroom. Intel transactional synchronization extensions enable execution of transactions that are independent in order to accelerate throughput. Intel TSX delivers outstanding performance gains for multi-threaded applications that are developed using a coarse-grained lock, which is a single lock for the entire hash table that behaves like a fine-grained lock, or which is multiple locks for smaller table sections. Coarse-grained locks are easier to use, easier to understand, and easier to debug. In summary, Intel TSX provides a set of instructions that allow programmers to specify regions of code for transactional synchronization. Programmers can use these extensions to achieve the performance of fine-grained locking while actually programming using coarse-grained locks. So P-state and C-state control provide the ability to individually tune each core's performance, and sleep states to improve application performance. This chart provides you with a quick reference to the individual Intel technologies that were explained on the previous slide and to which EC2 instance contains each Intel technology. For each instance, a few key technologies are identified to end customers because they have significant impact on the performance of some workloads. More details will be discussed later in this presentation, but for now, be aware that different instances have different instructions and capabilities that will affect performance beyond just frequency. Amazon EC2 lets you choose from several different instance types to meet your computing needs. Each instance provides a predictable amount of dedicated compute capacity and is charged per instance hour consumed. First generation general purpose instances provide a balanced set of resources and a low-cost platform that is well suited for a wide variety of applications. Second-generation general-purpose instances provide a balanced set of resources and a higher level of processing performance compared to first-generation general-purpose instances. Instances in this family are ideal for applications that require higher absolute CPU and memory performance. Applications that can benefit from the performance of a second-generation general-purpose instance include encoding applications, high-traffic content management systems, and memcached applications. High-memory instances offer larger memory sizes for high-throughput applications, including database and memory caching applications. High CPU instances have proportionally more CPU resources than memory and are well suited for compute-intensive applications. There are also various high storage and cluster computer instances or instance types available. Instance metadata is divided into categories. It is data about your instance that is used to configure or manage a running instance. Because your instance metadata is available from your running instance, you do not need to use the Amazon EC2 console or the AWS CLI. This can be helpful when you're running scripts to run from your instance. You are not billed for the HTTP requests that are used to retrieve instance metadata and user data. Instance user data can be used to build more generic AMIs that can be modified through configuration files supplied at launch. It is important to note that although you can only access metadata and user data from within the instance itself, the data is not protected by cryptographic methods. Anyone who can access the instance can view its metadata. You can specify user data to configure an instance during launch or run a configuration script. The Cloud Init package is an open source application built by Canonical that is used to bootstrap Linux images in a cloud computing environment such as Amazon EC2. User data is treated as opaque data. What you give is what you get back. The instance is responsible for interpreting that user data. User data is limited to 16 kilobytes. This limit applies to the data in raw form, not the base64 encoded form. User data must be base64 encoded before it's submitted to the API. The Amazon EC2 command line tools provide the base64 encoding for you. The data is decoded before being presented to the instance. User data is executed only at launch. If you stop an instance, modify the user data, and start the instance, the new user data is not executed automatically by default. This slide shows an example of user data on Linux. It is installing the Apache web server, enabling it, and starting it. You can send user data to a Windows instance with a PowerShell script or with a set of Windows batch commands. Here, using PowerShell, we are installing the Server Manager module, IIS, and the web management tools. To retrieve instance user data, you use the following URL on your instances. It starts with http://169.254.169.254/latest/user-data. Amazon EC2 purchasing options. On-demand instances are free tier eligible. They have the lowest upfront cost and the most flexibility. You pay for an hour at a time with no upfront commitments or long-term contracts. This is great for applications with short-term, spiky, or unpredictable workloads. Amazon EC2 reserved instance pricing allows you to reserve computing capacity for 1 year to 3 year terms at a significantly discounted hourly rate. Reserved instances provide a billing discount and a capacity reservation that is applied to instances to lower hourly running costs. A reserved instance is not a physical instance. The discounted usage price is fixed for as long as you own the reserved instance, which allows you to predict compute costs over the term of a reservation. If you are expecting consistent, heavy use, reserved instances can provide substantial savings over owning your own hardware or running only on-demand instances. Scheduled reserved instances enable you to purchase capacity reservations that recur on a daily, weekly, or monthly basis with a specified duration for a 1 year term. You reserve the capacity in advance so that you know it is available when you need it. You pay for the time the instances are scheduled, even if you do not use them. Scheduled instances are a good choice for workloads that do not run continuously, but do run on a regular schedule and take a finite time to complete. Spot instances enable you to bid on unused EC2 instances, which can lower your Amazon EC2 costs significantly. The hourly price for spot instances of each instance type in each availability zone is set by Amazon EC2 and fluctuates depending on the supply of and demand for spot instances. Your spot instance runs whenever your bid exceeds the current market price. Spot instances are a cost-effective choice if you can be flexible about when your applications run and if your applications can be interrupted. Amazon EC2 does not terminate spot instances with a specified duration, also known as spot blocks, when the spot price changes. This makes them ideal for jobs that take a finite time to complete, such as batch processing, encoding and rendering, modeling and analysis, and continuous integration. An Amazon EC2 dedicated host is a physical server with EC2 instance capacity fully dedicated to your use. Dedicated hosts allow you to use your existing per socket, per core, or per VM software licenses, including Microsoft Windows Server, Microsoft SQL Server, SUSE, and Linux Enterprise Server. Dedicated hosts and dedicated instances can both be used to launch Amazon EC2 instances onto physical servers that are dedicated for your use. There are no performance, security, or physical differences between dedicated instances and instances on dedicated hosts. However, dedicated hosts gives you additional visibility and control over how instances are placed on a physical server. Dedicated instances are Amazon EC2 instances that run in a virtual private cloud, VPC, on hardware that's dedicated to a single customer. Your dedicated instances are physically isolated at the host hardware level from instances that belong to other AWS accounts. Dedicated instances may share hardware with other instances from the same AWS account that are not dedicated instances. Amazon Virtual Private Cloud, or VPC, has four primary concepts I want to talk about today: subnets, security, network, and VPNs. With Amazon Virtual Private Cloud, VPC, you can define a virtual network topology that closely resembles a traditional network that you might operate in your own data center. You have complete control over your virtual network environment, and you can easily customize the network configuration for your Amazon VPC, such as a selection of IP address ranges, creation of subnets, configuration of routing tables, and network gateways. AWS assigns a unique ID to each subnet, regardless of the type of subnet, public or private. The internal IP address range of the subnet is always private. A public subnet has a route to an internet gateway, and a private subnet has no route to an internet gateway. Amazon Virtual Private Cloud, also known as Amazon VPC, allows you to provision a logically isolated section of the AWS cloud where you can launch AWS resources in a virtual network that you define. You have complete control over your virtual network environment, including the selection of your own IP address range, creation of subnets, configuration of route tables, network access control lists, and network gateways. You can easily customize the network and configuration for your Amazon VPC instance. For example, you can create a public-facing subnet for your web servers that require access to the internet and place your back-end systems such as databases or application servers in a private-facing subnet with no internet access. You can leverage multiple layers of security, including security groups and network access control lists to help control access to Amazon EC2 instances in each subnet. Additionally, you can create a hardware VPN, virtual private network connection, between your corporate data center and your VPC, which allows you to leverage the AWS cloud as an extension of your corporate data center. Amazon VPC provides various features that you can use to increase and monitor the security for your VPC. Security groups act as a firewall for associated Amazon EC2 instances, controlling both inbound and outbound traffic at the instance level. Network access control lists, ACLs, act as a firewall for associated subnets, controlling both inbound and outbound traffic at the subnet level. Amazon EC2 uses public key cryptography to encrypt and decrypt login information. Public key cryptography uses a public key to encrypt a piece of data, and the recipient uses the private key to decrypt it. The private and public keys are known as a key pair. To log into your instance, you must create a key pair, specify the name of the key pair when you launch the instance, and provide the private key when you connect to the instance. Linux instances have no password, and you use a key pair to log in using SSH. Windows instances require a key pair to obtain the administrator password and log in using RDP. You can connect your VPC to remote networks by using a VPN connection, such as AWS Hardware VPN, AWS Direct Connect, AWS VPN Cloud Hub, and or a software VPN. Storage services with Amazon S3 and Amazon EBS. Amazon Simple Storage Service S3 is designed to make web-scale computing easier for developers. Amazon S3 provides a simple web services interface that can be used to store and retrieve any amount of data at any time from anywhere on the web. It gives any developer access to the same highly scalable, reliable, secure, fast, and inexpensive infrastructure that Amazon uses to run its own global network of websites. Some facts about Amazon S3. There's a 100 bucket limit per account. You can store an unlimited number of objects in a bucket. The size of an object can be up to 5 terabytes, and there is no limit to the size of a bucket outside the size of your wallet. Amazon S3 is designed for 11 nines of durability and 4 nines of availability of objects over a given year. You can use either HTTP or HTTPS endpoints to store and retrieve any amount of data at any time from anywhere on the web. Most importantly, Amazon S3 is a highly scalable, reliable, fast, and inexpensive. Common use scenarios for Amazon S3 are storage and backup, application file hosting, media and software delivery, as well as storing AMIs and snapshots from Amazon EC2. You can also host a static website on Amazon S3 by configuring a bucket for website hosting, then uploading your website content into the bucket. To get the most out of Amazon S3, you need to understand a few simple concepts. First, Amazon S3 stores data as objects within buckets. An object is composed of a file and any metadata that describes the file. To store an object in Amazon S3, you must upload the file you want to store into a bucket. When you upload a file, you can set permissions on the object and add any metadata. Buckets are logical containers for objects. You can have one or more buckets in your account. For each bucket, you control access. In other words, you control who can create, delete, and list objects in the bucket. You can also view access logs for the bucket and its objects and choose the geographic region where Amazon S3 will store the bucket and its contents. Because the combination of a bucket, key, and version ID uniquely identifies each object, Amazon S3 can be thought of as a basic data map between bucket plus key plus version and the object itself. Every object in Amazon S3 can be uniquely addressed through the combination of the web service endpoint, bucket name, key, and optionally a version. Amazon S3 Security. You can control access to buckets and objects several different ways. With IAM policies, you can only grant users within your own AWS account permission to access your Amazon S3 resources. With access control lists, you can only grant other AWS accounts, not specific users, access to your Amazon S3 resources. Bucket policies in Amazon S3 can be used to add or deny permissions across some or all of the objects within a single bucket. Policies can be attached to users, groups, or Amazon S3 buckets, enabling centralized management of permissions. With bucket policies, you can grant users within your AWS account or another AWS account access to your Amazon S3 resources. For maximum security, you can securely upload data to and download data from Amazon S3 via SSL encrypted endpoints. The encrypted endpoints are accessible from both the internet and from within Amazon EC2 so that data is transferred securely both within AWS and to and from sources outside of AWS. Amazon S3 provides multiple options for protecting data at rest. Customers who prefer to manage their own encryption keys can use a client encryption library such as Amazon S3 Encryption Client to encrypt data before uploading to Amazon S3. Alternatively, they can use Amazon S3 server-side encryption if you prefer to have Amazon S3 manage encryption keys for you. With Amazon S3 SSE, server-side encryption, you can encrypt data on upload simply by adding an additional request header while writing the object. Decryption happens automatically when data is retrieved. Amazon S3 server-side encryption uses one of the strongest block ciphers available, 256-bit Advanced Encryption Standard, AES 256. With Amazon S3 SSE, every protected object is encrypted with a unique encryption key. This object key itself is then encrypted with a regularly rotating master key. Amazon S3 SSE provides additional security by storing the encrypted data and encryption keys in different hosts. Amazon S3 SSE also makes it possible for you to encrypt or to enforce encryption requirements. For example, you can create and apply bucket policies that require that only encrypted data can be uploaded to your buckets. Instead of using Amazon S3 SSE, you can also encrypt your data before sending it to Amazon S3. You can build your own library that encrypts your object data on the client side before uploading it to Amazon S3. Optionally, you can use AWS SDK to automatically encrypt your data before uploading it to Amazon S3. Versioning is a method of keeping multiple variants of an object in the same bucket. You can use versioning to preserve, retrieve, and restore every version of every object stored in your Amazon S3 bucket. With versioning, you can easily recover from both unintended user action and application failures. In one bucket, for example, you can have two objects with the same key, but different version IDs. If you version enable a bucket, it can never return to an unversioned state. You can, however, suspend versioning on the bucket. Lifecycle management defines how Amazon S3 manages objects during their lifetime. Some objects that you store in an Amazon S3 bucket might have a well-defined lifecycle. If you are uploading periodic logs to your bucket, your application might need these logs for a week or a month after creation, and after that you might want to delete them. Some documents are frequently accessed for a limited period of time. After that, you might not need real-time access to these objects, but your organization might require you to archive them for a longer period and then optionally delete them. Digital media archives, financial and healthcare records, raw genomics sequence data, long-term database backups, and data that must be retained for regulatory compliance are some of the kinds of objects you might upload to Amazon S3 primarily for archival purposes. When you configure a lifecycle rule, you specify the storage class you want to transition the object to and the number of days after object creation to transition it. You can transition objects to Standard Infrequent Access, IA, storage class, archive them to Amazon Glacier, or have them permanently deleted. Standard IA is useful for data such as backups and other older, infrequently accessed data where high performance continues to be a requirement. It is suitable for objects greater than 128 kilobytes that you want to keep for at least 30 days. There is a retrieval fee associated with standard IA objects. Amazon S3 pricing is based on capacity and bandwidth actually used. Because Amazon S3 is an internet-scale service that runs natively across an entire region, it can handle significant request throughput and bandwidth output. All bandwidth into Amazon S3 is free, but AWS charges a rate on bandwidth out. Most importantly, since Amazon S3 can handle any amount of data, it is important to note that you only pay for the amount of space you use. Prices are based on a prorated gigabyte per month. Amazon Glacier is a long-term, low-cost archiving service that is optimized for infrequently accessed data. It is designed for 11 nines of durability, but expect to wait 3 to 5 hours to get the data out of the archive. The primary benefit is cost. We go to less than 1 cent per gigabyte per month, depending on the region. Each object in Amazon S3 has a storage class associated with it. S3 Standard is ideal for performance-sensitive use cases and frequently used data. Standard is the default storage class in S3. S3 Infrequent Access, IA, is optimized for long-lived and less frequently accessed data such as backups and older data that is accessed less but still requires high performance. Glacier is suitable for archiving data where access is infrequent and retrieval time of several hours is acceptable. Archived objects are not available for real-time access. They must be restored before access is available. The Glacier storage class is very low cost. S3 Reduced Redundancy Storage, RSS, is designed for non-critical, reproducible data stored at lower levels of redundancy than the standard or IA classes, thus reducing cost. Amazon Elastic Block Store, also known as Amazon EBS, provides persistent block-level storage volumes for use with Amazon EC2 instances and offers consistent and low-latency performance. Amazon EBS is particularly suited for applications that require a database, file system, or access to raw block-level storage. Amazon EBS snapshots are durable and automatically replicated within their availability zone. Snapshots can be stored in Amazon S3. Amazon EBS provides block-level storage volumes for use with Amazon EC2 instances. Amazon EBS volumes are highly available and reliable storage volumes that can be attached to any running instance in the same availability zone. The Amazon EBS volumes attached to an Amazon EC2 instance are exposed as storage volumes that persist indefinitely from the life of the instance. When the volumes are not attached to an EC2 instance, you pay only for the cost of the storage. Amazon EBS, the Elastic Block Store, starts as unformatted space. The call to create a volume comes in from 1 gig to 16 terabytes. That volume is attached to an EC2 instance. It is formatted and mounted and used like any attached hard drive. As you use the hard drive, you can take a snapshot, back that snapshot up to S3. When you are finished with your instance, you detach the volume and release it, and it becomes unused space again. Amazon EBS volume types fall into two primary categories: solid-state drives, SSD, and hard disk drives, HDD. They differ in performance, characteristics, and price, and you can tailor your storage performance and cost to the needs of your applications. Amazon EBS volume types, again, fall into two primary categories. You can see from this slide that in the description, we balance price and performance from transactional down to the lower cost that is designed for less frequently accessed workloads. You can mount multiple volumes on the same instance, but volumes can be attached to only one instance at a time. EBS volumes behave like raw, unformatted block devices. You can create a file system on top of these volumes or use them in any other way you would use a block device like a hard drive. Amazon EBS is recommended when data changes frequently and requires long-term persistence. EBS volumes are particularly well suited for use as primary storage for file systems and databases or any applications that require fine granular updates and access to raw, unformatted block-level storage. Amazon EBS is particularly helpful for database-style applications that frequently encounter many random reads and writes across the dataset. The Amazon EBS service is simply a virtual hard drive. So a great use case for Amazon EBS is when you want the hard drive to persist past the life of the Amazon EC2 instance. Before Amazon EBS existed as a service, AWS only used physical local attached hard drives called ephemeral storage. The problem with that was that you couldn't stop an Amazon EC2 instance without losing all of your data because of the temporary nature of local storage. That's why we created Amazon EBS to decouple the lifecycle of data persistence from the lifecycle of an EC2 instance. Amazon EBS volumes are ideal for root volumes that you need to store and have block-level access to for your operating system, database storage, and data sets that are smaller than 1 terabyte. Given its simple snapshot mechanism, Amazon EBS is a great use case for simplifying distributed backups as well. Amazon EBS pricing is based on allocated storage, whether you use it or not. This is unlike Amazon S3, whose pricing is based on space actually in use. Prices may vary based on region or for IOPS. This table illustrates the significant differences between Amazon S3 and Amazon EBS. Amazon EBS volumes are network-attached hard drives that can be written to or read from at the block level. Amazon S3 is an object-level storage medium. This means you must write whole objects at a time. If you change one small part of a file, you must still rewrite the entire file in order to commit the change to Amazon S3. This can be very time-consuming if you have frequent writes to the same object. Amazon S3 is optimized for write once, read many use cases. The other major difference is cost. With Amazon S3, you pay for what you use, and with Amazon EBS, you pay for what you provision. An instance store provides temporary block-level storage for your instance. The storage is located on disks that are physically attached to the host computer. An instance store is ideal for temporary storage of information that changes frequently, such as buffers, caches, scratch data, and other temporary content, or for data that is replicated across a fleet of instances, such as a load-balanced pool of web servers. Use the local instance store only for temporary data. For data that requires a higher level of durability, use Amazon EBS volumes or back up the data Amazon S3. If you're using an Amazon EBS volume as a root partition and want your Amazon EBS volume to persist outside the life of the instance, set the delete on termination flag to no when you create the instance. This table shows the differences between rebooting, stopping, and terminating your instance. Note that using instance store volumes, when the instance is terminated, the instance store is lost.